Hi guys, here are the solutions to questions exercise 10b question 9 and 10c question 5. Okay, now what I would say is, I know a couple of you contacted me. Like question 9, I've just done it there now, and it's a very difficult question, right? So let's focus on getting the setup correct and looking at your work. You've done that, which I'm happy with, right? So we're asked to show basically that the range is something, and then asked to show what that maximum range is something, and then once you've done that, we just sub in the values given to us in the last part of the question. Okay, so this is what I'm really pleased with, right, is the setup. You all got the fact this is going downhill. Gravity, if this is y, this is x, okay, gravity is in the direction of x this time. Up the hill is going against direction. Still negative for y is going against direction, but it's in the direction of x this time, okay, for this component here and here, right? So you got that, great. And then you knew for the range. So I've done these out already, so I'm just going to go through them so you can pause the video, right? So then you know this. The standard procedure for getting the range is when Sx, we want the x distance when the y distance is 0, so we find an expression for the time, we should be pretty used to this now, and then we sub that in, okay? I'm very pleased that you all got this far. After this, it gets difficult. So what I've done here, and as I said, well, I don't think at this point, I think the only thing you can do is to multiply the brackets, right? So at this point here, we're looking at, so suppose that red line is where the minimum would be the expectation at this stage, because you haven't done trigonometry in maths, and a lot of what we're going to see now is experience in solving these questions over the next year or so, right? So when you get more of these, the more you try things out and maybe recognize it first time round, and you'll also know some of the trigonometric equations we use in maths as well, right? So let's look at this. So I just multiplied that out, right? Here, and there's a bit of cancellation there, so get your heads around that. This squared is 4u squared sine squared g squared cos squared, okay, and then the g cancel, etc. Then I've got this scenario here, okay, and this doesn't look anything at all like the show that part of the question. However, in the show that part of the question, it is factorized on the outside, right? I'll just give you the answer here. So r is equal to u squared g cos squared beta, and then inside, okay? And the reason I'm saying this is because when you get to this point, I've probably said this before, when you get to this point, you need to be looking between the two of them. How do I make this look like that? So if you look here, we've got 2u squared g cos beta, 2u squared g cos beta squared. We can still factorize, can we? We've got sine alpha as well, right? So I'm going to factorize that out because that's what it's got there, and I want to try and start making it look like that, right? I know at this point it's just kind of worms in your head probably, but just as I said, experience and going with what you're looking at the answer, looking towards the answer, right? So that's what I've got here. Okay, so you can say again that that's not really helping me, but inside the bracket then it's got like a double, in the show that part it's got like a double angle thing, right? So I've made this into, so if I multiply this one by cos beta top and bottom, and then have a common thing here, and this is a thing that you'll start to recognize, if not already, right? This, when you do these questions, particularly when even at the exam at the end of the year, have your tables next to you. So this is in the tables, right? As equal to sine of an angle times cos of an angle plus sine of an angle times sine of another angle is equal to this. So we can start to minimize this, right? So this becomes here. inside the bracket, and I've taken the cos beta to make this cos squared. So cos beta is cos squared, right? So again, when I get to here, so I've put that in there, and nothing's really working, nothing's really triggering, right? In the tables, you have this as well, which we're going to use. Okay. Again, I know this is relatively new to you, and I know you'll get better at this with more experience. So 2 times, so here we have sine of an angle, cos of an angle, right? So I put them together inside. So I basically just rearrange the bracket from here to there to allow me to use this, right? So I put the sine alpha inside there to make it sine alpha cos. I put the cos, you know, to make it cos squared here, right? So now I've got sine of an angle times cos of another angle, right? Sine of an angle times cos of another angle. In the tables it's 2 times this, right? So we can rearrange that to bring the 2 down. So sine of an angle times cos of another angle is half of this, okay? Which in our case, A is alpha, B is alpha minus beta. So alpha plus beta is alpha plus alpha minus beta. So 2 alpha minus beta. Alpha A minus B in our case is alpha minus this, so alpha minus alpha is nothing, alpha minus minus beta is positive beta. Okay, really tricky part there. And if you can get your heads around that, right, I'm not concerned if you can't at this moment, to be honest with you, and I don't think you won't get anything like this in the exam, but we do have to expect it. We have to try and get these sort of things ahead of next year now, right? Once you get to here, then there, I've implemented that here now. You know, things start to cancel and you end up with what was shown in the show that part of the question. Alright, so that's part 1. So this is the range. So part 2 asks for the maximum range, right? So if I go back to my drawing, and again this is important, this is experience for you now, right? If I go back to my drawing here, right? This angle is fixed. Okay. The velocity is fixed. Okay. Fixed. The only thing that can change in this question is the angle of which way we throw it. So which angle gives the maximum range. Okay. So I'm saying that for a reason, because we've worked out in the first part the range to be this. Now we said beta was fixed, it's the slope of the incline. U is fixed, that's the velocity given, right? So the only thing that can change here is this, right? Now we want this to be maximum. So we want the only part that alpha affects in this expression is there, isn't it? So we want this expression to be maximum. The maximum amount that sine of any angle can be is 1. Right? So we are saying the sine of 2 alpha minus beta is equal to 1. Right? Now that's actually 90, because we know that, well, we might not know yet, because sine of 90 is 1. So we could say then 2 alpha minus beta is equal to 90 from there, if we wanted a bit more information about any of these two. But it doesn't matter in this case, we just know that for the maximum range this is 1, okay? So there we have it. Sorry. That's it rewritten out. We know this is going to be 1, so I can write it like this. Okay, that's for the maximum range. Again, it does not look like to show that part. This is the answer we want. So we've got to get from here to there. Okay, and again, you know, we don't have cos in our answer, right? So we've got cos there. So you know, we've touched on this before. Cos squared beta plus sine squared beta is equal to 1. Right? You'll touch more on that in maths when you do the unit circle. Okay, so we can rearrange that. So we can call cos squared beta 1 minus sine squared. Put that in there. And then it's a trick with a difference of 2 squares. That's not a squared in there. Wrote that in by accident. Right, so let's go down here. We've got this now. We want to get to here. So if I make this is 1 squared minus sine squared beta. So then we've got the difference of 2 squares, haven't we? And they cancel. Okay, so really tricky question. For the last part, you just sub them in. I didn't do that, okay, but you can just do that for the values. Really tricky part, right? But this is what I'm looking for, and this is where the marks are as well, by the way. And I can't account for this because it's a textbook question, but you know, I'm not joking you when I say that sometimes if you even get to that point, this is where I drew the line at the start, you know, you're looking at 75 to 80% of the marks, right? Even more sometimes, right? So this is really positive, and I saw your answers, and you all got that, right? So the ones I looked at anyway. Well done. The other one I'm going to go through is the one with the landing angle, okay? Again, I've written it out because I didn't think it'd be much benefit to you to watch me just talking and writing. So here's the setup. Again, very pleased with the setup, guys. Well done. Interestingly, one of you, and I sympathise with you, here's the book here. I think because question 9 was going down the plane, it doesn't say in the question which direction this is going, so this is why I sympathise with you. But I think what I can tell you very confidently is, if it doesn't say that it's going down the plane, okay, so if you look at this question, for example, it says protected from the foot of an inclined plane, and here it just says the particle is protected with initial speed u at an angle to the inclined plane, right? So it doesn't actually say up or down the plane, right? It was up the plane, so I think Dylan maybe took it as down the plane, so I do sympathise with you on that one. I think unless it specifically says down the plane, score up the plane, I don't think, again, going back to the exam type questions, you won't get, it'll be much more clear. Anyway, so that's the drawing, okay, that's the setup, all very good, and I've listed this as well, because when you're talking about the landing angle, you need to know that. So going back to last week's class, this is our step, find the time of, so this speed is the speed just when it lands, okay? So that's the velocity there, Vy, Vx. So we need to find this right at the point of landing, which means we need to know the time of flight, okay? So find the time of flight in the usual way that we do when we find the range. Find the velocity in the x and the y direction at the time of flight and sub it in, and hopefully we get what we want, just inverse tan of 2 in this case. So find time of flight, Sx when Sy is equal to 0. Put it in. Now, halfway through this question, I actually regret that I did this. You can choose to put, so I've done this calculations here based on the values given in the question, right, which I always urge you to do. So Sy, if you look at my pen, is u sine beta t minus half g cos alpha t squared. So I've subbed it in here. You don't, I don't mind, you didn't have to do that here, but it just got a bit messy with the root 5 and all that, but it still works out. But I wanted to say to you that you can leave that as it is here if you wanted to and sub it in right at the end. Okay. However, I haven't. I've done it. So 1 over root 5 sine beta. Okay. Cos alpha is 4/5, right? So same again. You factorize u over root 5 minus 4g over 2 times 5 is 10. Okay. So t is 0, or this is equal to 0. Add this, multiply up, and divide down. You get the time of flight as 10u over 4 root 5g. Okay, and then we're going to sub them in now to dx and vy. Okay, so that's our time of flight. Okay, focus camera. Sorry, just waiting for the camera to focus. Okay, so u times cos beta, I'm taking these values again, 2 root 5 minus sine alpha 3 root 5, now t is this, okay? And then it's a case of just simplifying it down. So pause it there if you want in the video and see if you can do it yourself. So 2u root 5, 30u times 20 root 5, and I made it to, so I've got a fraction there, I need a common denominator, multiply bottom by 20 here, multiply top by 20, that's a mistake, they cancel out, that's what you get for the x velocity at the time of landing. Similarly for y, Again, just pause the video if you need to hear. You know, I've got just worked it out to be a common denominator, and as we expect, and as will always be the case, the y velocity will be negative, which is why this negative is here, isn't it? So it cancels out. I'm going to put it in u over root 5 divide by u over 2 root 5. So I've written this out differently because this is the way I like to explain this. U over root 5 divide by u over 2 root 5. Division of fractions, flip the second one, change it to multiplication, then we've got to go. Right? Okay, so that's that one. I do appreciate that, particularly question 9 was very difficult, right? I'll speak to you tomorrow.